As the world has aged, the fate of global economic growth appears to be reliant on more environmentally friendly and efficient production processes, especially as resources become increasingly scarce, carbon emissions have skyrocketed, and we are witnessing unprecedented climate change. With an estimated 7.3 billion metric tons of carbon dioxide emissions, the global transportation sector has developed into a significant polluter. As a matter of fact, 41% of all transportation-related emissions come from passenger cars, making them the main anthropogenic source of emissions. This evidently places automotive industries as key determinants in the global quest for zero carbon emissions. As Tesla and its rivals dominate discussions about who will rule the auto industry in the future, there is another type of green transportation technology that has gained traction and is built on the universe's most abundant resource. Automotive giants Toyota appears to have invested in hydrogen fuel cell technology, which offers an eco-friendly substitute for fossil fuels and can be used to provide flexible and high-density power and propulsion for a variety of industrial facilities and modes of transportation. Watch our video today, which looks at Toyota's insane new engine that is shocking the entire car industry. Although still fairly new on the market, hydrogen power cell technology has been available for years, but in an extremely limited capacity. Due to their high efficiency and environmentally friendly operation, fuel cells make an excellent alternative for internal combustion engines and boilers in the transition to greener industries. However, because fuel cells are a new energy technology, sizable market penetration has not yet been achieved. Nonetheless, this mode of technology, unlike conventional internal combustion engines, produces no tailpipe emissions, is more energy efficient, and only releases warm air and water vapor. Practically, hydrogen fuel cell vehicles are similar to electric vehicles in that they power the wheels with an electric motor rather than an internal combustion engine. Yet unlike electric vehicles, which must be recharged by plugging them in, hydrogen fuel cell vehicles generate their own electricity and do not require charging. A fuel cell generates electricity by combining hydrogen gas from the vehicle's fuel tank with oxygen from the air, leaving water and heat as byproducts. Fuel cells work in the same way that batteries do, but they do not need to be recharged. Electricity and heat are generated as long as fuel is available, which in this case is hydrogen rather than gasoline or diesel. Two electrodes, the anode, which represents the negative electrode, and the cathode, which represents the positive electrode, are sandwiched around an electrolyte in a fuel cell. Now, in order to generate electricity, the anode receives hydrogen molecules, which are separated into protons and electrons by a catalyst. These subatomic particles then take separate paths to the cathode, which receives oxygen from the atmosphere. Electrons flow through an external circuit, causing electricity to flow, whereas protons move through the electrolyte to the cathode, where they combine with oxygen and electrons to form water and heat. The beauty involved in this process is that fuel cell vehicles, like electric vehicles, have no tailpipe emissions that contribute to smog or greenhouse gas emissions. They are more energy efficient than vehicles with conventional internal combustion engines and only emit warm air and water vapor. Due to the fact that they don't emit any harmful gases, it eliminates the handling and storing of hazardous substances like battery acid or diesel fuel, which are no longer necessary. Also, hydrogen fuel cell technology has proven itself in harsh environments, such as cold environments as low as -40 degrees Celsius, extreme weather conditions such as hurricanes, desert sandstorms, and winter storms, as well as the demanding commercial environments of material handling warehouses. According to the U.S. Department of Energy, hydrogen fuel cells typically have an energy efficiency of 40% to 60%, whereas the typical internal combustion engine is about 25% energy efficient. In warehouses, hydrogen fuel cell efficiency can increase warehouse productivity by up to 15%, where hydrogen-powered forklifts can be refueled in as little as 3 minutes, substantially reducing vehicle and personnel downtime. A few high-profile names, however, have been unconvinced about the prospects of fuel cell technology. The most notable is the world's richest man, Elon Musk, who brandished the concept as extremely silly when the subject came up during a discussion with reporters at the Automotive News World Congress a few years back.
I don't want to listen to a debate on hydrogen fuel cells because I just think that they're extremely silly.
He points out that hydrogen does not occur naturally on Earth, so you must either split water with electrolysis or crack hydrocarbons, which he believes does not solve the fossil fuel problem, and points out that electrolysis is inefficient. While hydrogen is abundant in the universe, it cannot be used as fuel unless it is separated from other compounds. This procedure can be quite energy intensive. The amount of emissions associated with producing hydrogen fuels is determined by the source of hydrogen and the method of production. The majority of hydrogen used as a fuel today is derived from natural gas, but hydrogen fuel can also be derived from water, oil, coal, and plant material. Musk's battery or bust future strategy has not been embraced by the auto industry as a whole. According to a 2017 KPMG survey of 1,000 senior auto executives, they believe hydrogen fuel cells will eventually outperform electric vehicles and represent the real breakthrough, roughly about 78%, with the short refueling time of just a few minutes being cited as a key benefit. 62% of the respondents also agree that infrastructure challenges will be the undoing of the battery-powered electric vehicle market. His opinion hasn't deterred top automotive industry players like Toyota, who are excited about the technology's future. The automotive giants believe that the numerous environmental and social benefits to be gained from constructing a future society based on carbon-free hydrogen and renewable energy sources are enormous, and that this aligns with their long-term environmental Vision 2050, which expresses their desire to achieve true harmony between society and nature. Toyota began working on the development of fuel cell vehicles in 1992, but debuted the Mirai, a hydrogen fuel cell sedan, in 2014. Even though the name Mirai means future in Japanese, the flagship Toyota fuel cell system technology model was designed to be accessible and appealing to people today. It has a cutting-edge powertrain and runs on the unique fuel unit we all know as hydrogen. The Mirai is a standard mid-size four-door sedan that is as practical, safe, and easy to drive as a conventionally powered family car. On a full tank of hydrogen, it can travel as far as a comparable size petrol car, and refueling takes between 3 and 5 minutes. The benefits include a smooth, quiet drive, strong performance, and no tailpipe emissions other than water vapor. The Toyota fuel cell system in Mirai generates electricity by reacting hydrogen and oxygen. The fuel tank is filled up with hydrogen fuel in a similar fashion to buying gasoline or diesel at a gas station. The fuel is stored in high-pressure tanks before being fed into a fuel cell stack, where the hydrogen and oxygen found naturally in the air react to generate electricity. As in a petrol-electric hybrid, the voltage of the electricity is increased to power the electric motor, so that every time the car brakes or slows down, more energy is captured in a battery, contributing to even better fuel economy. With decades of hybrid electric technology research and development, the automotive giants have become the first in the world to create a system with a power density of 3.1 kilowatts per liter. The flagship Mirai has found over 5,000 buyers since its introduction. Along with the Mirai, Toyota has also contributed to the development of larger hydrogen fuel cell vehicles, which include the Sora bus and heavy-duty truck prototypes, and is considering using hydrogen in internal combustion engines in addition to fuel cells. While the Japanese automaker looks to move forward with plans for hydrogen-powered vehicles, firms such as Hyundai and BMW are also considering hydrogen fuel cell techniques. Honda has also made a significant commitment to hydrogen. There are currently nearly 1,100 Honda Clarity fuel cell vehicles on the road in the United States, and the company has partnered with Toyota and a Shell Oil subsidiary to build new hydrogen fueling stations in California. So far, 2 have been built, with 5 more in the works. Consumer hydrogen refueling stations are popping up all over the world, and in 2019, Toyota and Honda collaborated with Quebec's government to build hydrogen infrastructure in Montreal, and even oil-rich Saudi Arabia was scheduled to get its own station. Hyundai, which currently has 220 hydrogen fuel cell vehicles on the road in the United States, is also seeing an increase in sales. All current models have been integrated with ranges of more than 300 miles on a full tank and can be refueled almost as quickly as traditional gas and diesel vehicles, something the electric vehicles haven't quite been able to achieve yet. Several automakers are selling or leasing fuel cell vehicles in select markets, primarily in the US, where hydrogen fueling stations are already available. Stations are planned or under construction in the Northeast and Hawaii, and fuel cell transit buses are already on the road in cities such as Boston, Massachusetts, and Flint, Michigan. It is envisioned that this technology will be expanded over the next few years as infrastructure expands and technology matures. Because of the flammability of hydrogen, some people assume hydrogen fuel cell cars are not as safe. Yet, according to National Fire Protection Association statistics, an internal combustion engine vehicle causes a car fire every 3 minutes in the United States. The statistics also reveal that alternative fueled vehicles, which include both hydrogen fuel cells and battery-powered electric vehicles, are not more dangerous than traditional internal combustion engines. Although hydrogen is flammable, so are gasoline and lithium-ion batteries. Certainly, there are additional safety risks associated with transporting hydrogen for use at refueling facilities, but those facilities use sensors to detect leaks. In California, where the industrial sector has been transporting hydrogen for decades, there have not been any significant incidents reported. The main issue is that cars are still expensive, with a starting price of $59,345, compared to the comparable-sized Santa Fe's starting price of $24,250. Nexo is the most expensive Hyundai currently available for purchase in the United States. The manufacturer's suggested retail price for the fuel cell versions of the Toyota Mirai and Honda Clarity is about $59,000. However, as with any new technology, costs for fuel cells should decrease as the market expands and achieves economies of scale in manufacturing and infrastructure. To be fair, the development and implementation of fuel cell electric vehicles, as well as the extensive hydrogen infrastructure required to power them, are still in their early stages. Even so, there is reason to be optimistic, particularly given that the U.S. Department of Energy is leading research efforts to make hydrogen-powered vehicles a cost-effective, environmentally friendly, and safe mode of transportation. Under the Energy Policy Act of 1992, hydrogen is classified as an alternative fuel and is eligible for alternative fuel vehicle tax credits. Globally, if we can transition away from fossil fuels and toward alternative energy sources that tend to produce clean green energy, everyone will live in a much better and safer world. That sums up our video for the day. If you enjoyed this video, watch also the next video on your screen, which looks at how Norway got insanely rich. As always, give the video a like and subscribe to our channel for more exciting future videos.